Most multi-day hikers deal with wet clothing in adverse conditions, and 87% of the hikers that we surveyed responded that wet clothing was extremely uncomfortable. We set out to solve this problem with the trail dryer. Hikers often arrive at their campsite without enough sunlight or time to air dry their clothes, and this is where the trail dryer comes in. It must dry clothing relatively quickly and in all conditions. The trail dryer must be light and it must be relatively small, so as to not be cumbersome to the hiker or difficult while packing their bags. The trail dryer consists of 4 major components. The outer 3D printed cylinder encases the device. This enclosure is attached to our Gore-Tex flexible shell, which collapses for easy packing. The heating pack is made of a sodium acetate solution and takes advantage of a reversible exothermic chemical reaction to generate heat. The hanging rack is a 3D printed part that holds the heating pack and the clothing together in a 1 1/2 spiral and locks into the enclosure. The fan, housed in the top of the enclosure, draws air into the device from the top and expels it out the bottom, carrying away the saturated water vapor. Creating the trail dryer focused on 3 primary goals: maximize the wet surface area receiving airflow and heat, generate the heat and airflow under strict power restrictions, and minimize the packing requirements of any device we created. To achieve our design goals, we employed an iterative design process, which involved the rapid deployment of testing protocols and prototypes with a fast turnaround time in order to optimize our final product. We explored many possible suspension systems, but the final iteration employs a spiral hanging design to deliver airflow to the entire shirt in a much smaller footprint. To generate heat without the use of an electric element, we explored the use of propane, but discovered the device would lose practicality if employing a fuel source. This led us to sodium acetate, the compound that is commonly used in reusable hand warmers. As the reaction can be reset using boiling water, it is a reusable, low-waste solution which can sustain high temperatures for an extended period of time. Testing of the final prototype found that our design dried clothing over a reasonable time period, which varies by how damp the item is, and should be especially impactful during nighttime when sunlight is scarce and temperatures drop. Under these conditions, the trail dryer shines, and hikers can tackle their next trail comfortable and dry.